Looks
Okay,
good.
so yeah, you're ready to go? Go.
Okay. Hopefully this is good for Mike. Hey everyone, I'm Caleb Ziems. I'm a PhD candidate at Stanford. And in this lightning talk, I want to discuss how cultural awareness, a theme of this workshop, is helpful for building more human-centered large language models. So in my brief 10 minutes, I want to quickly cover ideas from 3 of our most recent papers. First, I'll pull from our survey at the top on how human-centered LLMs work and how to build them. And we argue here that we need human-centered design to address users' concerns and values, not only during post-training, but at every stage of LLM development. And in response to that argument, critics might say, well, there's the bitter lesson. We don't actually need design tailoring AI to specific human purposes, because more parameters and more training data will give us better models for any natural language task. So if scaling laws also solve human simulation, we can just simulate user feedback. So in the second paper, our simulation scaling laws empirically show that cultural biases will get in the way. Scale helps models understand people in general, but not people in particular. So we need real human data and human participation to build human-centered LLMs. And so now that we need human contributions, we're left with the challenge of elicitation. How do you actually procure valuable contributions from a wide variety of people? And we answer this in our EMNLP paper, Culture Cartography. So first, human-centered design. Design is the deliberate construction of systems like LLMs to achieve a specific purpose. And human-centered means that we're focusing the design purpose on the needs of particular users and user groups like cultures. Our paper argues for human-centered design across the entire LLM pipeline, from system ideation to data collection, training, eval, and deployment of models. So we make our point with a case study actually on the future of work, a topic of tomorrow's discussion. And here, one design challenge is actually eval. Benchmarks may show that LLMs have the capability to productively collaborate with workers, but real usage logs may show failure modes due to things like the gulf of envisioning, or the distance between users' goals and their actual prompts. But this gulf assumes dialogue-based prompting, implicit in NLP training methods like the assistant template of instruction tuning. But what if models were more proactive? An alternative paradigm from our lab actually shows that models can learn about you by observing your interactions with your computer and anticipating your needs before you ask. But such proactive systems require very human data, like a user's file system and screen capture, which these may raise massive concerns over privacy. And privacy itself is actually a human-centered problem, since different users have different norms and expectations around how their data should be handled. So again, we need more human data. We go on like this to build an increasingly dense web of spaghetti, as you can see on the screen, all for the purpose of emphasizing our point that human-centeredness isn't just alignment. It's actually a design approach across the entire LLM pipeline, which requires human feedback, steering, and data. So now, what if we could just simulate human data? Sure, we might not have faithful human simulators yet, or maybe we do. But we might argue that scaling laws apply, and we could expect this soon. That's why in this work, we actually look at scaling laws for social simulation. And ultimately, we find systematic cultural biases that remind us we actually need real humans in human-centered research. So although this paper considers a bunch of different domains, I'll focus the lightning talk on opinion simulation, which is very helpful for anticipating the needs of user groups for design, and it also could be helpful for training or steering more culturally aligned models. Prior work actually shows that large language models struggle with faithful opinion simulation in one particular way that we saw. Post-trained LLMs are quite prone to mode collapse, or just defaulting to the average perspective rather than generating the full distribution of valid perspectives. And for example, there's a Nature Machine Intelligence paper that shows GPT-4 generates simulated perspectives with significantly less topical and stylistic diversity than human respondents. Our study evaluates scaling on the World Value Survey, the largest and most comprehensive set of global opinion surveys to date. And the task format is MCQ, with questions like, how would you rate the importance of family in your life? So we ask here, will scaling, or actually the current trajectory in language modeling, improve social simulation with large language models? Our notion of current trajectory here is defined from open leaderboard results following the methodology of observational scaling laws that I'll explain briefly. So the key insight of the method is that just a few capability dimensions explain most of the variation on a diverse array of LLM benchmarks. And you can think of these as capability dimensions that can be computed by a low-rank decomposition, or PCA, on the model performance matrix. In particular, the first principal component explains more than 60% of general capability benchmarks like MMLU and ArcChallenge. So we use this as a proxy for the current trajectory of language modeling. You can see on the x-axis, we have general capabilities, the first principal component. And then on the y-axis, the vertical axis, we have task loss, given as the KL divergence between a model's logits and the ground truth human opinion distribution from the World Value Survey. So the alignment between the model and human opinion distributions. And we find that opinion simulation is not uniformly aligned with general capabilities. In the case of Canadian opinion simulation, general capabilities explain 60% of the variance in simulation performance, as you can see here with this pretty tight regression fit on the left. But then on the other hand, in the case of Pakistani opinion simulation, general capabilities explain only 6% of the variance, seen here with a much looser regression fit on the right. So here's a larger range of the scaling results we observe. And from these, we actually notice that discrepancies in scaling seem pretty consistent with distributional imbalances in large language models pre-training data. So to test our hypothesis, we approximate distributional imbalances by counting the country-specific keywords in a random sample of the DCLM pre-training corpus. Specifically, we count named references to the top 10 most populous metro areas of each country, and then they correlate that with the cumulative log frequency of their scaling law coefficients. And we find a Spearman correlation of 0.8 and a Pearson correlation of 0.7, which is quite large, between observational fit and pre-training term frequency, which starkly supports our conclusions about pre-training bias. The implication here is that for underrepresented sample populations, LM survey simulations will not reliably improve as much with scale. And we actually need real human data from these cultures and from these populations if we're going to support distributional alignment. As I mentioned before, we're left with the challenge of elicitation. So how do you actually procure valuable contributions from a wide variety of people if you need this human input? We show some of the shortcomings in current approaches for this, and then we propose an alternative with this EMNLP paper, culture cartography. So one method for eliciting cultural knowledge from people is this kind of traditional annotation. The approach often fails to represent users because all the power is in the researcher's hands. The researcher decides the questions of interest, and then the annotators just passively answer those questions. The annotator can't really steer the process and provide insights that they think matter the most. An alternative paradigm is knowledge extraction. It kind of flips the setup around. The target population here is naturally producing culturally representative data on the web, like on social media. And then the researcher extracts this data and codifies it for evaluation or training or other research purposes. So the researcher here actually can't steer the distribution now towards questions of interest, like those that actually challenge language models or complement their knowledge distribution. Our proposed method, culture cartography, ties both of these issues together and tries to solve them both, eliciting data that's both representative of users' needs and out of distribution for current models. For representative data, we let the human steer, and for OOD data, we let the LLM identify the challenging questions. And this is kind of what it looks like. So here, humans freely edit and contribute salient questions of interest. And then these contributions condition actually how the language model generates potential answers. With uncertainty estimation, the language model actually highlights its low confidence answers here in red, allowing the humans to focus most on the knowledge gaps or where the language model fails, making appropriate edits and contributions. And by iterating kind of in this way between the LLM and the human, they together co-construct a tree of knowledge. And we call this whole approach culture cartography. We expect our approach will have advantages over traditional methods, like specifically traditional annotation. We expect cartography should represent users' interests more, and the data should be more complementary and distinct from language models' knowledge. We show this empirically. So here we compare data with culture cartography in purple against what was produced with traditional annotation in the teal color on the bottom. and we evaluate the recall of leading models producing that same knowledge given the prompt. We find that language models recall significantly less of our culture cartography data than what was produced with traditional annotation. And our method is generally then more effective at eliciting data that matters to users and is distinct from what models already know. So to conclude, I think I'm out of time, but I covered these 3 papers. First, I argued for human-centered design in every stage of LLM development. And then I argued why human-centered design actually needs real human data contributions from a wide variety of cultures. And third, I explained how you can elicit meaningful data contributions by this kind of human LLM co-annotation, this mixed initiative approach called culture cartography. So I hope you can check out the papers for more details, and I'd really be happy to chat with you at the lunch and anytime during the breaks. Thanks.
Let's thank our speaker. Okay, so thanks Caleb and Vishak for giving your lightning talks. Again, there are time for a couple questions, so I've put some in, but we can also get your questions. So again, if you can join the Menti and you can ask questions or upvote some. So first question to Vishak. How would you model barging in a rollout means to decide not only how to react, but also when to react? I wonder whether you can unmute and tell us your answer for that.
Yeah, I can. Yeah, thanks, Brofman. I think I can probably explain this by saying so. One detail that I didn't exactly mention in the talk was that so basically, like, because our interviewer has like multiple agents that are responsible for different things, we have a shared memory called an interviewer agenda. And basically, the planner writes topics into the agenda, and then we have a separate agent that does the asking to the participant. So essentially, this like sharing of responsibilities is modular and it's modulated by that shared memory. So I think this sort of like well, we do rely on like ultimately like the agent to decide whether or not like when to ask which question. So it is LLM directed in that sense, but the like shared memory stops it from being like a stop start, if that makes sense. I'm happy to like answer some more if needed.
Okay, thanks, Vikash. Can we get any questions to Caleb or Vikash from the room? Okay, we have a question here.
Hi, Prakash. Raymond here. My question is actually regarding, so I can't remember the exact term you used, but when basically your questionnaires diverge or your AI, what's this called, qualitative researcher diverts from the brief. My expectation is basically all of that information is going to be unique effectively, right? So what's its use in terms of a study? Because I think generally studies are oriented towards getting statistical power or showing commonalities, right? So you're going to have a lot of things that are very divergent. So I mean, how do you incorporate that into your studies?
Yeah, I think that's a really good question. And like the workflow that I imagine is sort of like when you do your initial interviewing, you sort of like keep increasing your pilots at like different scales, right? So sort of you observe the emergence across multiple like sort of increasing pilots, and like depending on if there is something consistent that you didn't anticipate, you could add it to the script, the topic guide for subsequent interviews, if that makes sense. So like essentially like we think of this as part of the like study. It should inform the subsequent study design. Does that make sense? Because I totally agree with you that like some of it would just be outliers and like some of it would be like the actually like meaningful things. But I think this is the sort of like aggregation challenges we need to solve as we scale this to like larger populations. Does that make sense?
Yes, okay, great. Caleb, you have a question as well. So what do you think about the potential loss of agency when agents infer and fulfill needs before people are even aware of their needs?
This is a really good question. I think broadly for this workshop is to be thinking about agency in the future of work. I think agency is kind of will be a product of the design of systems. And I think there are systems that can be much more proactive without taking away people's agency. I think this is the model of collaborative intelligence that we're, I think, in this workshop talking quite a bit about. So I don't know if we have much time to go into detail, but I do think that there's possibilities to have collaborative agents that are more proactive, infer and fulfill needs, but still leave the human collaborator an agentic role in deciding the trajectory of the collaboration itself.
Wow, what a perfect answer. And so for that, we're going to have agency and have our lunch. So let's thank all of our speakers, Caleb and Vikash. So we'll be back here at 1 o'clock because there is a timing for the NAI workshop, the keynote. We'll be using a different Zoom address, which I will relay to you of those of you who are virtual. So we have about 45 minutes for lunch, and please go ahead and partake. Thank you so much. We'll see you back at 1.